Hi, this is Steve Carroll, and welcome to episode number 52 of Going Native. Today we wanted to talk about the standards meeting, like we always do when they happen 3 times a year. But today we wanted to look at it through a particular lens. Since C++ 17 is starting to firm up, we really wanted to look at it through the lens of what is C++ 17 going to mean, not just for library implementers, but what does it mean for the 95% of devs who just write code in C++, and what's it's going to look like, and what are the types of features that are really going to matter to every dev. Okay, so welcome to Going Native. I'm Steve Carroll. I'm the dev manager for the C++ team.
Gabriel is first on the C++ team.
And we have a new friend today. Casey, introduce yourself.
Hi, Casey Carter. I'm in the C++ libraries group.
Cool. So today's topic is Oulu, Finland, and the C++ committee meeting there.
That's right. It was northern Finland. The sun would go down around 12 a.m.
A.m., okay.
And come back around 1 a.m. When I say comes back, doesn't mean it was dark. It was there.
I see.
So it was exhausting. I had 10 hours jet lag, and it was interesting.
Got it. Jet lag plus. Okay, so what would you say is the top line, big accomplishment of what happened at the committee in Oulu?
So the big thing is that at the end of the Oulu meeting, we have the contour of C++ 17, what it would look like. People doing software release will say RC or that kind of stuff.
I see.
Or if you're
it's kind of like we're feature complete, and we're at the point where
yeah.
we're just taking critical bug fixes.
That's right. So, and we have this critical document that we voted out. We call the CD, the committee document. So.
Okay. That is the most generic name ever, but okay, fine.
You want the WD?
You guys are the best at bureaucracy. This is fine, let's go.
Working document?
Working document, all right.
Yeah, so this document is very important because it contains all the features that we want, we believe C++ 17, yeah, that's what we expect it to be. And we'll send it out to national bodies for comments. And this is a very important step in the standardization process for C++ 17. Yeah.
Got it. So what would you say is what is C++ 17 as a whole? Now that we have a sense of where we're going to land, how would you characterize it?
C++ 17 takes forward something we started with 11, which was that when you write code, we want your code to be shorter, more correct, and more efficient. And 14 came with generalized const expert and remove some other stuff, variable templates, and make it even much better. Now with 17, we take that further, right? So on the core language side, we have a couple of features and a bunch of stuff on the library side so that we take away the boilerplate from your code, most of the buggy boilerplates from your code.
I see.
I don't know. And Casey can tell you more about the library parts in a few minutes.
Would you guys characterize it as a major version?
So we wanted 17 to be a major version. That was what we thought 6 or 7 years ago. And a lot of things happened. You remember the Jacksonville disaster.
That was a good episode.
Yes. And after Jacksonville, Oulu, felt like we were in Candyland, right?
Okay.
We got everything we expected to land except operator dot, but it's on track. It'll be back, and so it felt really good. And I would think 17 is just like 14, where it is medium release, but with significant features in libraries.
And I guess we've really established this cadence concept at this point.
Yeah, so now we got this every 3 years train model.
It's you believe it the third time, right? Yeah.
Yes.
Yeah.
So we want to make it happen the third time and be on track for that. And this is a real accomplishment. So there have been some talk, should we delay? And it was, no. We really want the train model. We just need to be more efficient.
I got it.
Yeah.
Okay, cool. So, what does C++ 17 code look like, right? So, what is the major takeaways here, right?
So yeah, that's a very good question. The first thing that you want to know is that you have two kind of features in 17. You can look at 17 through the laundry list of featurettes. Like if you're going to buy hardware, oh yeah, I got 3 gig of,
Yeah.
But no, what you really
And we'll make sure that we have like a link so that
Yeah.
if, in case you haven't already seen it, like the laundry list of micro things.
But the thing that affects most developers, when I say most developers, I mean people outside the community, is how it impacts your day-to-day code writing. The first thing is you're going to have things like structure binding that allows you to return multiple values and decompose them at a call site. This is very important. When you have APIs like that takes output parameters. Now you don't need the output parameters because they tend to be bug farms, right? You just return a status, the outcome, and the value that
sort of paired up.
That's right. And then
This is the brackets.
That's right. And you decompose that at a call site, right? It's very, very nifty. And something quite nice happened independently of structure binding was proposal to generalize if conditions and switch conditions where you can initialize a variable and then write a condition. So you can actually decompose your outcome of computation and then test whether you expected the right amount of work. So example of that would be, let's say you're processing some kind of command line configuration files, right? You're going through a bunch of directories. If you're looking for a file and you don't find it, that is not exceptional. So you just want to return it, return some kind of error code or something like say, oh, I didn't find it here, please continue. That's a natural place where you say, oh, search for this file. And if you find it, then do the action otherwise continue. And you don't need to throw exception and try catch.
Got it. So in some ways you think like the fingerprints of C++17 code is you'll find these sort of structured binding things in places where you normally would have had like out parameter kind of scenarios.
That's right.
And the ability to kind of do variables inside of...
Or if you were actually doing multiple return values by returning tuples.
Yeah.
And having to use standard tie and that whole mess to
Yeah.
get something like what structured binding does in a really simple way,
Yeah.
then
So-
you can clean those up too.
That's right. So a couple of months ago, Biani actually gave the background behind structure binding, and I just probably tell people here is that we're doing the core C++ core guidelines, and we're on the chapter on initialization, and Biani and I was like, no. Code should look like this. If you want a variable, you declare it and you initialize it. That reduces bugs. And her pointed out, how do you handle auto parameters? Like, oh yeah, that's good catch. And then he went away, and the next day he came back with this idea of structure binding, and we work on it. And so I get the outcome here is that when you design language, you design for how people use it as opposed to, oh, I want to have this feature. So we came from the perspective, this is how people should write code and how you make the language fit that. And this is why it's going to change. Now, when you look at 17 code, that's how you recognize 17 code. Yeah. And then we have a bunch of other, feature stuff, and the list will be in the links that will be there.
Got it. Any other ones you want to call out here? We've got a list off camera.
Oh, yes. Yeah. So, structure binding that make your code much more robust, and simpler. In simplicity, you also have deduction of template arguments.
Sort of like auto for that, right?
Yeah, something like so. We used to have pair, for example. If you want to have a pair of a string and a double, you say pair of string double, then you say make pair, right? And that make pair is just there so you don't have to repeat the argument. That's just kind of bureaucracy. It's wiped out after water. And with a proposal from Mike Spertus and Richard Smith was like, well, if I say pair and I have foo and 25,
the answer is obvious.
It's
You've
obvious.
autoed the rest of the
Yeah,
language.
why should I need to repeat that? So that's going to bring simplicity. Code's going to be much simpler to read, to write, and will be more correct the first time you write it, right? Because when you specify those arguments, sometimes you're vulnerable to implicit conversions that you didn't intend, right? So now, you don't have to repeat yourself, and the first time you write it, it is correct.
And that's actually a pretty good transition. So you were mentioning things that you didn't expect. And I think there were a number of features that were kind of brought into C++17 that you could think of as peace of mind features. Yes. Places where we kind of clarified behaviors and made it harder to fall into traps, right?
That's right. So first, it will be elision of temporaries, now copy construction in elision, that has been C++ has been kind of, oh, if your compiler is smart, it'll get rid of it. If it is not smart, it won't do it, and in the confusion. And now, as a C++ programmer, it is guaranteed. It will be removed, so you don't have to.
So you have more
worry
predictable
about it.
performance characteristics.
Yeah. So behavior and semantics behavior, and yes, algorithmic performance characteristics, more predictable. And the other one, which I had my fingers in, was order of expression evaluation. That's kind of 40 years problem. It's been there. We for some reason we believe that if we leave the order of evaluation unspecified, we call it function and supply argument list. Today in C++ 17, sorry, in C++ 14, the order of evaluation is left unspecified, and worse than that, the evaluation can interleave.
Yeah, I think there was I think the famous example when you were first explaining this to me that really made it connect for me was, I think there's like a bug in the book, right? In Bjarne's book.
Bjarne's book. So Bjarne had this very nice book, which is a reference book, right? And it is reviewed mostly by programmers.
Pretty smart guys.
Yes, including people on a committee, so people who actually write the rules, right?
Yeah.
And I think there was about 12 of them among the reviewers, and none of them caught the bug. And the bug was actually not caught by a human. It was caught by a tool. And the expression was simple. Everybody believed what was happening is what they're saying.
Advertisement. Run static analysis against your code using
right.
Visual C++. Thank you. All right.
and it turns out if you have these, the elites can't find the problem, then how do you expect the mass to do it? And so what we did was just remove the bug. You remove the bug, not by removing the example, but by fixing the language. And now the order of evaluation is more predictable than it used to be. We went in there with the expectation that we'll have, for function calls, left to right evaluation of the argument list, but we ended up with it's indeterminate, but no interleaving, and we fixed the bugs in the book.
And I think there was also a typo in the book, and so we're changing the English language. We're announcing that today as well. There's new spellings for words.
So I would like to point out something interesting here, I think we didn't cover before, was that the community has been very worried about losing any kind of performance to C or some other language. So what we did here at Microsoft first was to modify the front end to enforce blindly left to right evaluation, and without changing the optimizer or any other. And we found, we ran benchmarks, and we found that
a lot of different things,
yeah, it was kind of surprised, though some benchmarks went up. You wouldn't have expected that, right? The thing you would expect it was they would go down. So we got downs and got up, and they were in the range plus 4%, minus 4%, and and then, interestingly, Jason Merrill from Red Hat, working on GCC, also did the same experiment. No change to the back end, only the front end, enforcing evaluation. And he found, he ran Spec 2006, I think, and found that, well, for the most part, didn't change anything, except there was one that was down 2%. My belief was, well, it is 2%. We haven't worked on the optimizer yet, so. We should keep that and go on, but eventually the committee as whole decided not to enforce left to right, but to ensure that there is no interleaving. And that is, strictly speaking, it's peace of mind. You don't have to worry about those things anymore.
Okay. But I think one of the things that we've said about C++ 17, now that we know what it looks like, is in some ways it's libraries heavy, right?
That's right. Most of the features we got are in library, and I'll let Casey go over.
C++ 17 was actually kind of interesting from a library perspective, because this is where we started seeing the pipeline that we've been filling since after C++ 11.
Particularly with the TSs,
right? We've been filling TSs with library features and iterating over those library features. And in 17, some of those are finally starting to come back into the IS, right? The things that are really under high demand, like string view and optional, that have been, well, I want to say languishing in the library fundamentals TS, that we're finally getting into the standard now.
So it's like libraries fundamentals v1 is sort of booked in almost completely with some asterisk, right?
Right. Yeah, almost completely. There was one or two small features that were left out because of lack of implementation experience. The library group, we didn't feel were ready yet to go into the IS, but almost the entirety of library.
So which of those are the ones that, like, our goal with this episode was sort of to talk to the things that we thought that the 95%ers of C++ developers would be. So, like, what are the things that were in the library's fundamentals that you feel like people will actually for sure be using to see those fingerprints of C++?
The first and biggest one that everybody is going to be using, you know, in 3 months is definitely string view.
Okay.
Yeah.
String view is a universal way to represent strings. You know, every project that every one of us has ever worked on has had 3 or 4 different string classes. Every library you've worked with has 3 or 4 string classes too, right? There's Qt string and C string and standard string.
I like beasters.
String. Everybody has a string type.
Yeah. And for the most part, they don't actually write into a string, they just want to read, right?
Right, yeah. For the most part, you want to pass these strings around to things that are going to read the contents of the strings. And string view is the perfect middleman for that. It's the lingua franca of string types. Everything ends up being convertible to a string view, and then interfaces can accept string views, and they understand all of the string types that you have to work with. It's a great vocabulary type that's going to shrink interfaces.
That's awesome. What else? What else from let's stick with the fundamentals for now. So
sticking with the fundamentals, optional is another big piece. Optional gives us a great way to pass things around that may or may not actually exist, which is incredibly convenient for interfaces. When you want to return something that is optional, we've in the past had to use pointers for that, right?
Right.
Well, this may not or may not exist. I have to return a pointer, and then I can use null to encode the fact that this thing's not really there. Optionals give us a way to do
really
that with
encode that
objects.
semantics.
Most people get a pointer and then dereference right away, right? You don't
Right,
check.
right.
Yeah,
They don't check it.
So with optional, you know, the only way you get a value out is you check.
Explicit.
Yeah. Where am I?
You have to explicitly
That's right.
pull the value out. And there are 2 different ways to do that, right? There's the dangerous way for the people that don't really care and assume that it's going to work. And there's the safer way, using a value member of optional that'll throw an exception if that optional doesn't actually contain a value.
And then is any from the fundamentals? Is that?
Yep, any is also in there. It's the other big one. Any is a type erased kind of wrapper like optional. It can hold any type at all, and you can put types in and pull types out.
It's sort of like the void star of.
Yeah, it's like the type erasure void star.
but you still have some kind of safety, right? Because
yeah, exactly. You can put anything into it, but it knows what's in it. So when you try to pull the wrong type out, it will explode and throw an exception.
Yeah, so I think
unlike void pointer, which just does terrible things when you.
Yeah, and I think there is one,
Terrible.
one data type which I consider fundamental that went into library that generalized both optional and any. Variant?
That would be variant.
Okay.
Variant was kind of the crowning achievement of Oulu for the library group, right? It was the big thing that we got in that we were all working on. There was actually a round of applause.
We were on the edge, right? We were on the edge.
Yeah, we were on the edge of not being able to get it in.
We had thousands of discussions online, offline.
Nobody does
hundreds of
suspense,
emails
like
over and over.
nerds and
It's been discussed at every committee meeting for what, the last year and a half?
Reddit was on fire.
Yep. Axel Naumann went through 8 different revisions of the paper.
Axel did a fantastic job.
And there were 2 revisions of the paper that weren't really revisions of this paper, but were different designs that he presented also as alternatives, because the committee was really, really concerned about getting variant right.
Yeah, and it is a type-safe replacement for the most part of unions.
For unions,
right?
yes.
So you don't have to do the union and then scratch your head. Oh, was it double? I don't really know. Was it straight?
Again, it's all about eliminating common types of errors that programs make.
That's the common thing.
Language helps you instead of allows you to aim the gun directly at your lovely shoes.
That's right. Yeah, that's the common theme with 17, which is the first time you write it, it is correct, and it is shorter, and it is more correct. And so we introduce all these types in there.
And ideally, just as performance.
Yes. Oh, yes. Yeah. Performance is nobody is going to we're going to sacrifice performance for that. Yeah.
So I think that covers library fundamentals and variant, which was the late minute edition. File system, I think we've talked about before. I mean,
That's right.
we're talking about this today in context of everything that got added. We're not just trying to look at what happened in the meeting. So file system is in, and that's exciting.
Yes.
I think you definitely see a lot of usage of that. What else?
Other features that made it in, the parallel STL algorithms
Oh, the first
other
episode of Going Native I ever made was on that.
the next other big one, right?
The beginning of the Carroll
the
administration.
contents of the parallel TS.
Yeah.
Right, we were talking earlier about how the train model is working with the TSs. We rolled the parallelism TS in Jacksonville, actually. So almost all of the algorithms that are present in the standard library are going to have parallel overloads.
Right, and if you're interested in that, we'll leave a link to the bottom so that you can. We did actually a whole episode on this, and it's as easy as just adding, var or par comma to get the thing running in parallel. And I think we wanted to talk about elementary string conversions, right?
Yes.
That one was new to me.
Yes, there are how many ways in C++ to turn a string into a number or a number into a string? There's at least a dozen that are listed.
So now there's a dozen plus one. There's a baker's
right.
dozen.
Exactly, just like XKCD, right? There's too many standards. We should fix it. We should make just one. Yeah. But anyway, elementary string conversions are nice because it is the lowest level, fastest possible implementation of this idea of going back and forth between strings and numbers. This thing just turns integers into character strings and character strings into integers. It doesn't do memory allocation. It doesn't go through IO streams. It's not sensitive to locales. It doesn't allocate memory. It doesn't do virtual calls, any of that stuff.
Yeah, you don't need to use stdio.h. You can just stay within modern C++ and get the performance.
Yes, C++ 17 will be able to turn integers into strings as fast as Python can.
I hope better.
At least as fast as Python can. And yeah, probably significantly faster.
Okay, anything else we want to talk about in libraries?
Those are the big things that we did in Oulu. Most of the library work we did in Oulu was polishing up everything that had been moved into the standard in earlier meetings. People saying, hey, this thing that we moved into the standard is great, but it's not quite right here, or the semantics aren't quite right there. So the library group reviewed at least 30 papers that were just changes to prior things that we wanted to get into the standard
and in
before
some ways
the CD went out.
At risk of kind of blowing through my outline, like one of the things I think we want people to come away with from this episode is that to be that person in that story, right? Grab these things, play around with them. We do have bug fixing coming up in the standard, and we want to make sure that we can find those sorts of issues before we book it.
Yeah, the committee document CD is almost by definition this is a buggy standard. Sorry.
Right. Yeah.
Help us find fix the bugs. And I think you have your hands in the range.
I am the author of the range TS now. Actually, I mean, a year ago, my presence in the C++ community is I was Casey on Stack Overflow, and that was pretty much it. Nobody had ever heard of me.
Hi, Casey on Stack Overflow.
I went to a C++ meeting in Lenexa, and somehow Eric Niebler inveigled me into working on the ranges TS because I was a little too excited about concepts and wanting to make things happen. And so now I'm here working at Microsoft, and nobody's more upset than me that concepts and ranges didn't make it into C++ 17. Yeah. But I'm working as hard and as fast as I can, so we're definitely going to have that in the next revision of the standard.
So can you give us update status and where range?
An update on ranges, what the ranges TS in general is currently mired down in the library working group because LWG's job is to go over every word of every proposal, every comma, every semicolon, and make sure that it's right. So the problem is that with a 220-page long proposal, it's really kind of hard for people to find time to go through all of that. So we've been through maybe 3/4 of the wording, and I've replaced maybe 20% of that wording since library went through it the first time, and they need to go through it again.
Cool. So I mean,
again,
this is the train model, right?
But
we're working on a train. We'll catch the train when it's ready, and Casey's pretty much full-time job is working through ranges.
So that's the spec. But now, if people want to try this, they will go to.
Oh, if people want to try ranges, there's my implementation that uses concepts and of course needs
GCC.
Another vendor.
That's okay, we can say
library.
GCC.
That's fine. That's fine. We love GCC.
The niche trunk GCC with its concept support.
Yeah.
That's available on GitHub at kccarter/CMCSDL2. The big one, of course, that everybody's probably heard of already is Eric's implementation, Range v3, that uses an emulation layer for concepts so that it'll work in C++11. That's also available, again, on GitHub at /EricNiebler/range-v3.
And I think the compiler team is working very hard to help
Yes.
you. Right?
Yes,
Stay
the
tuned.
Visual C++ compiler team has been working incredibly hard on getting Visual C++ to be able to compile Range
Right.
v3.
So that
And I've been kind of
eventually-
working on approaching from the opposite direction. So we're hoping that we'll be able to
Drill that old spike in the
announce
middle.
something in the foreseeable future for
Yeah.
range support with MSVC.
And right now, it's largely like expressions fine bugs, I think, is
Yes.
the right thing.
Yes,
Which,
expressions
if you've
fine,
been tracking our
some
compiler
two-phase lookup
releases
stuff.
and some two-phase lookup stuff that we're trying to work around.
Basically, the template model things that are getting worked through
Right.
heavily in the compiler right now.
We wanted to talk about voting rules.
Oh yeah. So
This is an interesting.
yeah. So usually, you have the featurettes, but here this is kind of administrative thing that I just wanted to mention to folks. A few years ago, ISO changed the rules about how to vote, and eventually you needed to be in some global directory maintained by ISO. And then they discovered that per nation, they had a limit, they had limits. Like, if you're programming Fortran, you can have dynamically allocated array, right? So you cannot have more than hundreds experts from a given country. And for the US, that's the problem. So,
This is part where we're supposed to go USA.
yes, or
USA.
USB. So, what we decided inside PL16 is to say, well, to go. We went to the entities that sent big constituents, right? Like Google, Microsoft, and to some extent EDG and so on. And so on. They were all happy with the fact that we can go back to the idea one company, one vote, and that's what we're going to do now within PL16. The U.S. National body. It's going to be one company, one vote.
I think everybody was pretty.
Yeah, everybody was very happy with that, and that removes the ISO, stuff, and so that's just a little change in the rule, but it is not something new because that's actually what we used to do, something close we used to do up until 14.
And my understanding is that's how the final voting on the standard paper.
Yeah,
That's always
you're
worked.
absolutely right. So at the
Strategy.
ISO level, it is national body, so it is one country, one vote. So the US has the same voting power as, let's say, Switzerland. So, as a conclusion, I think we want folks to go. The first thing for them is please go to isocpp.org. You get links to the papers, and by the time this video is out, you also get the post-Oulu mailing, which contains the list of, a copy of all the papers, motion that have been formally voted into the CD, the committee draft, or committee document. And please read them, help us find bugs, submit feedback. This is very important. Most of the features also have implementations in compilers.
Somewhere,
Yeah, somewhere. VC, Clang, GCC, please go try them, give feedback. We really, really need feedback. The committee is useful only when it serves the community, and we can serve the community only when we hear from you.
Right. All right. So that's it.
And see you.
What's next? Oh, the next one.
Yes, the next one. It will be in Issaquah here.
Yay!
In November.
Maybe I'll drop by.
Yeah.
You guys try to keep me out.
We're going to travel to exotic Issaquah.
Exotic
Yeah.
Issaquah.
Sunny Issaquah in November.
That's right.
Bye.